All right, this week we're going to learn a couple of input devices. So far, we have learned a couple of output devices. And well, briefly, we introduced the sense hat emulator and, used actually one of the sensors on the device. Sensor is also a kind of input device. So we're going to learn actually a few sensors as well in this week. And once you're introduced to a couple of those, and the rest are kind of relatively easy. So they kind of work the same way. So let's start with the buttons. And before we talk about buttons, we actually need to talk about switches. So switches are very simple electronic components. And a switch is a component that can disconnect or connect the conducting path in a circuit. And it does one of the two things. Either it interrupts the electric current, basically close it or open it, or it can divert the conductor from one another. And the particular use case here we're going to looking at is basically the interrupting the circuit situation. So here's an image of an assortment of switches. And some of them you can probably easily recognize. For example, this at the bottom left corner is a light switch. A specific kind of, actually it's called a toggle switch because this toggle here, you can turn on and off and they will stay in that position. And you probably have seen this, this is a button here. And this is another type of switch. This allows you to, essentially it's a different flavor from that toggle switch. This is essentially a rocker switch. It's like in your house, you probably also have that kind of a switch. It's like a paddle type of switch. It's square shaped. And there's actually a variety of different kinds of switches. You can use those switches at different places, and so comes in different sizes and shapes. And of course, the working mechanism is the same way. And there's actually two types of switches. We can categorize the function of a switch in two ways. One is so-called biased switches. This biased switch is sometimes called a momentary. Actually, momentary probably is a better, easier to remember name. What that means is it has a mechanism that can change the switch into a different position when you release it. So like if we push a button, that button bounces back to another, to the original position. This is a biased situation. That push button is a biased. So I just kind of mentioned a button that you already kind of can figure out that a button is a switch. It's just another kind of switch. And then we have unbiased switches. And a easier to remember name would be latching. The latching really says what it does. A latch, it will basically fix the state in a particular position. And so this will maintain its set position once operated. So like this, for example, the toggle switch. Once you toggle this to one side, it will stay in that position until you change it again to a different position. So that's kind of the unbiased or latching. So that's the two kinds of switches. And so as I just mentioned, the buttons are switches. And so a button, sometimes called a push button or simply just button. The button is actually a simple switch that is used to control an aspect of a machine or a process. Now here I show you examples of a small electronic buttons. They are used in electronic devices. You see my buttons everywhere. And so these are actually very small button switches. And these buttons, they are actually less than the size of a nickel, I think. Well, actually, it's about the size of a let's see. Yeah. So anyway, it's very small. So the one on the left that actually has 4 legs. This is one that is actually it's a momentary switch. This is the kind that you have in your kit. And we're going to use this in our example. And this one we don't have is a latch and switch. It's, basically once you push down, it will stay in a position. And then you push again, it will, come back. So basically, that's kind of the latching situation. It will stay fixed in a position. This has just 2 legs. And let's take a closer look at this momentary button. This momentary button, you see 4 legs. What the heck? Why do we have, what's the meaning of these 4 leads? And in fact, it just has actually, two. It actually just have 2 leads, practically speaking. Because the A and D, if you kind of look at this A, B, C, D in this counterclockwise manner, A and D is connected and B and C is connected. So that when you push the button, then a conductor will be pushed down to connect these 2 sides. So it completes the circuit. And that's when the electricity, the current flows through. And then when you release it, it is off. So this is when you push down is on and the release is off. So this is basically the momentary switch. And in terms of direction, so when you do your wiring, you need to just remember this. Either you connect, this 2 leads on one side or the other. So you kind of look at this leads that are coming out of one side, and you use either these 2 or the other 2, basically. And the other 2 is simply for you to mount this onto the breadboard. It's just how it's designed. So yeah, it does have a little direction when you're connecting. Just make sure that you're not really connecting this B and C or A and D, all right? Because the B and C is always connected, okay? So make sure you use either C and D or A and B. So just remember this direction. One side has nothing and the other side has the leads coming out. And then that's really where you have a control. This is what the switch is about, okay? Now let's actually look at an example. We're gonna put this onto our breadboard. And here's what we're gonna do is a simple example to control the LED with a button. And this is our trusty LED. Now you have seen this many times. And then we're gonna also have a separate circuit to connect to this button. Connecting the button is very straightforward. So you use 2 leads on one side of it. Basically, there's no polarity, so you just connect the one side to the ground and the other side to a control pin, right? So we'll have just any one of the GPIO pin will work, okay? So this is what I have here, and then this has specific number of pins, and this is what I'm going to be using. There's a pin 18 and pin 25, and this is the ground, all right? Let's take a look at an example. Let's take a look at the circuit here. Just ignore this bunch of wires here. This is something else I'm connecting to, and I'll introduce in a different video. And so, as you see, we have an LED right here, again with the resistor to protect the circuit. And the button is kind of wide. The only way you can mount this, so kind of be there's a little direction here, as I mentioned about, A, B, C, D, remember? The circuit, the side that has 2 leads coming out, make sure these 2 leads are plugged into different rows, okay? Not on the same row, but onto different rows. So it does have a direction, make sure you get this right. And then because it's so wide, And then we actually will only need to use one side of it. And so make sure you just have this cross uh, two sides of the breadboard, right? It's separated by a middle line. And then, because if you put this onto just one side, then you have no place to plug your wires. So you want to do something like this. What I've shown you here, this is one way to do it. Pretty much the only way to do it on our breadboard. You can position this a couple of more holes, to the right if you want. I like to have a little more space, so I do it this way. And so when you plug these wires, and you need to aim it at the leads, where the leads go into the breadboard, this is what the row is going to be connected with. So not because the size of the button, this covers a number of rows, but really the leads are inside a little narrower. So you just connect those. So this goes to the GPIO pin, and then the other side, the other lead goes to the ground, right? So that's the connection. Okay. Okay, so let's look at the program, and we're going to run a simple program on about this. We're going to control the LED with the button. We want to push the button, the light comes on, and release it, it will turn off. So let's look at the program first. So very simple program. We're going to use our GPIO0 library here, and we're going to get a LED class and button class. We want to use those. So we'll create a LED and a button with the GPIO pin numbers provided here. And with the button, we define the behavior. The behavior is defined by using these properties on the button. Say when pressed, when we press the button, when we press it down, what do you want to do? So this is the action on the, you assign an action to that when pressed attribute or property. And this, what's passed in is a function or a method of an object. So in this case, we're pressing in the method of on of the LED object. This basically means that when you press it, we're going to invoke the on method on the LED object. So it will turn the LED on. And then when you release the button, and then we're going to basically turn off the LED. See that? So it's very straightforward. And we're going to do a signal pause here so that the program will be waiting for signal and allow us to see the buttons working in action. Okay. And let's take a look at, so what I'm going to do, I'm going to just run this and I'll just demonstrate with what is happening here. So remember previously we had to use our program to control the LED on and off. And now we actually use the button to control LED on and off. Okay. So I just run this. It'll be just basically hanging there. And now so I just turned on and turned off. You see that? Okay, so that's pretty basic here. And as you probably realize, you can obviously use this button to control, take any action that you desire. And that's actually make a little change here. What if, let's say, well, because this is a momentary button, what if we want to do something almost like a toggle style switch that you have in the house, or actually the latching, right? The latching kind. So we can actually, simulate that situation by saying, let's say, well, whenever you release it, well, we don't care about when you press it. Whenever you release it, this is say we're gonna toggle the LED. Okay, let's say we're gonna just use the toggle method. Basically means that whenever you release the button, you push and then you release. And then it's going to toggle the LED. If it was on, it's going to become off. If it was off, it will become on. So keep changing that, just like the light switch, that the toggle switch that you do that, right? It's almost like simulating the on off with, without, because this is a different style. Now we can just basically change that by, turning this on and off iteratively. Okay, so let's see how this is going to be working in action. Let's kind of run this guy. And by the way, because this is a signal pause, the way to exit your process, typically just press Control-C to get out of the program. Okay, so I'm going to run this again. Okay, so I'll demonstrate that the working of this button. See, this will behave a little different now. Okay, so that is the, we press once, it turns on, press another time, it turns off. Now, there is one more mechanism I want to show you with the button, how it works. So I'll leave this toggle as is. Now, what I want to do here is there's another dimension, like how long you press the button for. So that's well, I'm gonna actually adjust the whole time. By default is 1 second. I want to just adjust that to 2 seconds by in this constructor of the button class, give it 2 seconds for the whole time. So I also say when held. So this is another action we can define, the when held handler, and we need to give it a function. Let's say I'm going to define a function, button held. We'll simply say, button held. Okay. And we'll use this function here. So if I hold the button for 2 seconds, my expected behavior is going to execute this function, which will print button held. Okay. So I'll show you what's happening here in the terminal. And now I'm going to just go ahead and hold the button, and then you'll see this prints out. So that was about 2 seconds, maybe a little over 2 seconds, because the action of a pushing and releasing, that's also kind of when you're counting. But anyway, so that internally within the button function, the when held is actually counting. That's kind of roughly 2 seconds. So I'm doing it one more time. Okay, so that's a long hold. And as you notice, actually, for some of the devices that you have at home, and it may take that kind of action. So you need to hold this for a certain number of seconds, and then it will do something different. And then even your cell phone probably has that kind of function, the power button, right? So this is a different way. Now, let me also gonna show you now here. I want to just kind of explain real quick here. Typically, you define a function, and then there's actually this function that you pass in. You can take actually a parameter, and this parameter will be the button object. So if for whatever reason you need to access the attributes of the button object, the button state, you can actually pass in a button object here. And let's say I want to know, how long the button was active for. Button was active for, how many seconds. Okay, so let's see. So button has a active time. Okay, the active time property. That's basically how long you have activated the button, how long you have pushed down that button. Okay, so we'll see what this value. This value should be really close to that 2 second that we set as the hold time, and I'm gonna push the button and hold and see what happens there. Okay. Hold on, I need to restart the program. Okay, so I did it twice. There was even a bit of delay when it was printed out. So the operating system is not a real-time operating system. So there's sometimes it's a little bit unpredictable when you get the message printed out into your screen. Okay. So anyway, the reason you see a delay between this and what I actually operated on the circuit is because there's a communication with the SSH, and so there's a bit of delay in that kind of a communication. So as you see, the actual value was actually happening as detected by the program is roughly, it's just a tiny little bit over 2 seconds. And that's when this button held function was called. Okay, that's really what we expected. And now let me show you also in the case where you say you have a, if you have a function that's really simple, that's just one statement. In that case, you can use a lambda expression. So you may be familiar with the lambda expression in other languages, but the Python lambdas are kind of fairly limited. Typically you can only write a single statement in that. So the equivalent way of writing this is to defining a function. Now, if you do something a little bit more than this, just a print statement, one in that you can probably still want to use a function. So suppose you just want to use, for our particular case, you can also just write a lambda. You can write a lambda expression, lambda button, and then I'll say, well, I'll just print this. Okay. So, okay, so this is one way to do it. And now I can delete this one. So I'm gonna run this and I'll press down the button. So you see that it's the same as before. This is a lambda expression. This takes one, this is the one argument. The lambda expression is meant to be pretty short typically. So this is a relatively long because the message, if you don't have, let's say if you don't have a parameter, then you simply just will do, like this, lambda colon, and that particular expression. So if we say we do this, this is one without the parameters for the lambda. Okay, so that's it. That's what I want to show you about buttons. It's a very simple device.